Hey y'all, let's get started with tonight's independent practice. Please remember that this is due tomorrow, okay? All right, first thing, before I get started, I did put some notes here on the top of the yellow worksheet. Please take note that I have a mistake up here, okay? It should not be ax2, it should be ax squared. So please fix that before we move on. All right, on the top here, I'm quickly going to go over the notes that we have. They are typed out for you here. But the first one is a cannot ever equal 0 in a quadratic. Okay. If we have a parabola that is opening upward, that lowest point is called a minimum. All right, and that is when a is positive, it will open upward. When our a value is negative, it will open downward and it will have a maximum value. Another important thing we talked about is the axis of symmetry. That is the dashed line that cuts the graph symmetrically in half. So whatever happens on the left side of the axis of symmetry is the exact reflection on the right side of the axis of symmetry. Okay. The Y-intercept is always 0C. Step 7 here, identify one more point on the graph. I'm going to call that optional. Sometimes it asks you to find another point. Today in class I did not ask you to, so I'm going to cross that off. However, it is there where you could pick any other x value, substitute it into the equation, and you would find that extra point. Okay. What I really want to hit on though is number 8. This is stating the domain and range. There's a lot of different ways to write the domain, and we talked about the domain is from negative infinity to positive infinity, as long as the parabola has arrows on both ends and there is no breaks in the parabola. Okay, so, or no breaks in the graph. All right, so you can write negative infinity to positive infinity, all real numbers, or our newest symbol that we came up with that looks like an R with 2 lines in front of it. The range is the one that we've got to be a little more picky with, okay? The range is going to be y is greater than or equal to, or y is less than or equal to. We're going to use y is greater than or equal to when it is a positive parabola, okay, or when it opens upward. And we're going to use y is less than or equal to when it is a negative parabola. Okay, I'm writing on question A here, but question A is your homework tonight as well. All right, so for the sake of the video, I did say I was going to do B, so let's go ahead and get started with this one. I did put some notes on the left side here, all right, that I was going to be talking about. They are also on top, but I just wanted you to see them. Given the equation negative x squared plus 6x minus 8, we are going to find all these points and graph it. So our a value in this case is negative 1. Our b value is 6, and our c value is negative 8. Okay. Since a is negative, it's a negative number, the negative parabola is going to open down. Negative people frown. Okay. In this case, if it was a roller coaster that was traveling on this parabola, it would start from down here, it would get to this highest point, that would be its turning point, and then it would start decreasing. That highest point is going to be called a maximum. Okay. So let's go ahead here, we'll notice that it's going to be a maximum. Let's circle that now and get that out of the way. Okay, now we got to find the vertex. We are first going to look for the x value of the vertex using the formula x equals opposite b over 2a. Opposite b is negative 6 over 2 times negative 1, which is negative 6 over negative 2, which can be reduced to 3. So the x value of our vertex is 3. Okay. Now we have to substitute that x value back into the equation, the original equation, so that we can find the y value. So we're going to have negative x squared plus 6 times x minus 8. We're going to plug in this 3, substitute the 3 in. 3 squared is 9 times negative 9 plus 18 minus 8. And that simplifies to positive 1. So the y value of our vertex is positive 1. Okay. Now, the axis of symmetry, that is the same value that we have for the x in the vertex. Okay, so don't go do any extra work. You could do that negative b or that opposite b over 2a again, but you've already done it, so why do it twice? Okay, so we're going to have x equals 3. The y-intercept is 0, c. So the x value is always going to be 0, and our c value in this case is negative 8. All right. Now we're going to create a table, and we'll come back to the domain and range here. Okay. All right. So our x values and our y values. Whenever we're talking about a table, always try to put that vertex right in the center, because it kind of helps us see where that axis of symmetry was going to go when we graph it. So the vertex is 3, 1. Okay. The other point that we already know is the y-intercept. That's also an ordered pair, so it is a point on the graph. The y-intercept is 0, negative 8. Since 0 is smaller than 3, on the table, I'm going to write it before negative 3. Please remember that the vertex causes symmetry or is symmetrical. That means whatever is happening on the left side of the axis of symmetry is also happening on the right side of the axis of symmetry. So what I mean by that is, from the vertex, how did I get from 3 to 0? Well, I would have subtracted 3. What if I wanted to go to the other side of the axis of symmetry where the x is? 3 plus 3, that would be 6. Okay. Also, if on the y-axis it's symmetrical from y to negative 8, on the other side it's also going to be negative 8. Okay, that's symmetrical. And we'll come back and check this to make sure that we did that correctly. Okay, all right, let's go ahead and graph what we have. And what I have here written in black. That's what I'm going to graph first. Okay, so I have 3, 1. Okay, that's my vertex. I am going to draw the axis of symmetry. I'm going to graph the y-intercept of 0, negative 8. And because it's symmetrical, from the axis of symmetry to the y-intercept, I went over 3 units to the left. So what that means is on the right side of the axis of symmetry, I'm also going to go over 3 units to the right. That's where my next point is going to be. Excuse me. Okay. Now, I want to check, though, to see if that point actually matches. Does that one match with what I said? So is it at 6, negative 8? Yes, that point actually is at 6, negative 8. Now that I see these 3 points and I can see that it looks like it would open down, I'm going to go ahead and create my parabola. Okay. Put an arrow on both ends to show that it does continue on. The domain value on this one, well, our domain, since there's no breaks in the graph and it does go left to right, is going to be all real numbers, whichever way you choose to write that, symbolically, negative infinity to positive infinity, whichever you choose to use. Okay. The range on this one, we are going to have to use y is greater than, or y is greater than or equal to, or y is less than or equal to. Okay. Well, going back up on top where we wrote down those notes, okay, we said if it opens downward, then it's going to be y is less than or equal to, and this is going to be, get a different color here, the y value of the vertex. Okay. So it's going to be y is less than or equal to 1. Okay. All right, that is it for the assignment. You've got to go back and do example A. But I did say we were going to do those notes so that tomorrow we can practice in class. Right? So let's go back to the packet we were working on in class today. Okay, we're going to finish this up here. So the y-coordinate of the vertex of a quadratic function is the maximum value or the minimum value of the function. These values represent either the greatest or lowest possible values of the function can reach, like a roller coaster. How high can a roller coaster go? How low can a roller coaster go? Okay. If the graph opens up, it is going to have a minimum value whenever the a is greater than 0. It opens down, that means that the a value is less than 0. Okay, so if it's less than 0, it could be a negative number. All right, that's going to have to be any negative number. Could be a fraction or a whole number, decimal, as long as it's negative. Okay, so here is a model. On this one, it has a minimum value. Okay, so that means all the other all the other y values would be higher than that minimum. When we write this one, it is always going to be y values are greater than or equal to whatever the y value is of the vertex. On this one here, all these other points are lower than the vertex. Okay. So this one here is going to be y is less than or equal to the y value of the vertex. Okay. All right. Example 4.2.3, maximum or minimum. Look at that a value. Okay, we always talked about that. A is -4. This is what's going to tell us if it's opens up or opens down. B would be 12 and C would be 18. However, all I'm focusing on right now is the a value. So determine whether the function has a maximum or a minimum. Well, if a is negative, and negative people frown, okay, I'm gonna find that turning point. That would be right here. That is the highest point, so that is going to be a maximum. State the maximum or minimum value of the vertex. That is going to be the y value. So in order to find that, I'm going to stick with what we practiced so far. Finding the axis of symmetry, okay, and then we're going to find that y value. So for this one, we're going to go with x equals opposite b over 2a. That's going to give us the a or the x value first. Okay. So -12 over 2 times -4. Right, or -12 divided by -8. Negative divided by a negative is a positive. 12 divided by 8 does not come out nicely. So on that one there, we are going to reduce that to a positive 3/2. Okay? All right, so x equals 3/2, or if you wanted to, you could write it as 1.5. All right, now that we've got that, we have to plug that back in to the actual equation. Okay, so really we're saying f of 1.5. Right, so we have -4 times 1.5 squared plus 12 times 1.5 plus 18. All right, so let's figure out that value. So we would take all that information, plug it into our handy dandy calculator. Okay, 1.5 squared, or 1.5 times 1.5. All right, so let's get that one first. That gives us -4 times 2.25. And then we're going to do 12 times 1.5 gives us positive 18 plus 18. -4 times 2.25. That gives us -9 plus 18 plus 18. So -9 plus 36 gives us 27. Okay, so when it says state the maximum or minimum value, the x is going to be 1.5 and the y value is going to be 27. Okay. State the domain and the range. Well, it's a parabola. It's got no breaks in it. Arrow to the left, arrow to the right. So the domain is going to be all real numbers, however you write it. Okay, whether you write -infinity to positive infinity, whether you write all real numbers, so however you write it, so you can identify what you're talking about. The range on this one, because it's opening downward, is going to be y is less than or equal to, and it's going to be the y value of the vertex. Okay. All right, that is it for these notes, and I will see you all tomorrow in class. Have a good night.